Hello guys, in this video we'll be looking at the Facade Design Pattern. The Facade Design Pattern is a structural design pattern that provides a simplified interface to a complex system of classes. That is, let's say we have multiple classes which all come together in order to work together. So through the Facade interface, we can interact with all these classes as a. So by just creating the instances of the Facade class, we will be able to interact with all those classes, all those subsystem of classes that we have. Suppose we have multiple classes that will contribute to an operation or application. We can use the package design pattern to create a unified interface through which we can access all the instances of these classes. Now, without further ado, let's see how we can implement this in our S code. So now in S code, the first set of things we'll do is to create some classes, which we will call them subsystems. So let me call this class CPU. So we are going to declare some method in this class. I'll call this phrase. So for brevity, we won't be implementing this class. Let's create another method. I'm going to call this jump. And this is going to take a parameter of position of type int. Let me say position type int. This also we won't be implementing it, so let's say this. And finally, I want to create another method in this class. Let's call this method execute. This will be parameterless, and we are not going to be implementing this as the other one. So now let's create another class. We call this class memory. And this class we can call it method perform load. We call this position. Of type int. And also let's pass it data here. This data is going to be of type string, data of type string. We won't be implementing this class as well, so let's just open and close the curly braces. And finally, I'm going to create another class. And I'm going to call this class func read position of type int and size of type int as well. So for this class, let's return a string. So return reading the hard drive width, size, then we'll pass our size inside here. So this is size and position. Also pass the position variable here. So now let's now create our package class. And don't forget, through this package class where we can now interact with all these classes, all this system of classes which we have created. So whenever we need to perform operation, we don't have to start creating an instance of all these classes one by one now. So because they all work together at the end of the day. So let's create this. So let's say class. Let's say computer package. This can be any name though. It doesn't have to have a package. So let's create an instance of this one quickly. Say private let the CPU first, CPU of type CPU, private let, let's say memory of type memory, and then lastly let's say private let, say hard drive of type hard drive. Let me change this to a capital case, to camel case. So now let's initialize all these classes which we say init self dot CPU. Let's assign this to CPU self or hard drive. Let's assign this to the hard drive. Then self dot memory. Let's assign this to the memory. Now we are going to create two methods. First method I want to create is called start. Let it func start. So this method will take in nothing and return. We take in no parameter and return nothing as well. So let's just do this. So say compute CPU, sorry, CPU dot freeze method CPU. Okay, let me use memory next. Let's say memory dot load, and then I can pass the position of 0 and a string of, say, reading data. Now let's call CPU, no, frozen it before, let's say CPU dot jump. Let me put this at position 0. And then finally in this method, let's say CPU dot execute. Now let's also create standard method. So let's call this method fetch data. So method fetch data. Then this is a parameterless function which return a string and then I can say return hard drive dot read. So let's pass position of 0 and size of some number. Let me call this 1024. Now we are done with creating our package class through which we can now interact with all the functions and methods in our subsystems. So now let's create an instance of this package class. Let's call it compute. Let's say let's compute assign this to let's assign this to computer facade. So now we can call the method of start, the type method on this, and say computer.start, and then we'll start our system, and then let me now assign this. Let me assign this. Let me create a view data, and then assign it to compute dot fetch data, and let's print this data to the console. So let's say print say data result data. So let's run this and see what we have. So now I can now see now that we can have our data being read and printed to the console. So in summary, this is what we've done. So to implement the packet pattern, what we do is we take the following steps. We first create some subsystems. And these subsystems are just individual classes that make up that complex. So they contain actual implementation and logic of various tasks which we wanted to achieve. So now we now create a package. That package is just a single interface which I can now interact with all our as we see in our code. So this class provides a simplified interface for complex system. As you know, which class within substance are responsible for which task and its delegate client to request as appropriate. So guys, this is the end of this video. Please don't forget to subscribe, share, like, and comment. See you in the next video.